Okay, so if we read through, I know you've already read through this, but it's really worth us reading through this again. It says the population of the zebu cattle in a particular country. Zebu cattle, let's just actually have a look at a picture of one. It might make it a bit easier to figure out what's going on here. Okay, so we're talking about these people, okay, these kids here. Not people or kids, sorry. These beasts, these weird cow breeds, the miniature zebu, the world's oldest, and oh, they're actually quite sweet. Okay, so we're looking at these zebu. They're just a type of cow, okay? But it's a bit weird, right? And it says the population of the zebu cattle in a particular country is modeled by two subpopulations, adults and juveniles. In this model, the only factors affecting the population of the zebu are the birth and survival rates of the population. Okay? What's the survival rate going to be talking about, do you think? What kind of things is... Yeah, it's like what percentage of them are surviving and what's the possible reasons that they're not surviving? Pardon? They could just be dying, they could be hunted, there's so many different factors. It's just worth thinking about these kind of things as it comes through, okay? Data recorded in the years preceding 2018. Preceding, what does preceding mean? Leading up to, yeah, ahead of 2018. So this data was used to suggest the annual birth and survival rates. The results are shown in the table below with values to two significant figures. It is assumed that these rates will remain the same in future years. You know when they say like, oh, what's wrong with the model? As soon as you read that, you should be going like, well, it's probably that's a sentence there that makes you think, well, it's probably not going to remain the same in future years because there could be other factors that happen. So whenever you see something, you think like, that's a bit weird. Maybe it's good to just take a note of that in case you're going to need to say that later. Okay, so this table, let's just actually understand the table. The birth rate where it says 0.23 with the adult population, what do you think that's actually meaning? What do you think the 0.23 means?
How many adults give birth?
Yeah, so what, like, compared to the adult population, what percentage of them are giving birth, right? The survival rate is telling me that 3% every year, 3% of the adult population are dying. We don't know why they're dying. They could just be dying to hunting, like death, like illness, all sorts of things like that. Obviously, the juvenile population have no birth rate because they're not giving birth because they're juveniles. Juvenile just means young, obviously. And then the survival rate is lower for the juveniles, probably because they're easier to be like hunted or like other animals are like preying on them more, okay? Then we've got this other bit where it says it's also assumed that a third of the surviving juvenile population become adults each year. So there's another factor that's telling you that a third of whatever this population is going to shift from the juveniles up to the adults. So it then says, let AN with a little n, the subscript n, and JN be these respective subpopulations in millions of adults and juveniles n years after the 1st of January 2018. So the adult population in the year n plus 1 satisfies this equation. Now, when it's saying the n plus 1, that's just saying if you know what this year is, you can work out what the next year is. So the adults will be 0.97 AN. Why 0.97 AN? Because 3% of the adults are dying. So we're going to say the number of adults next year will be 97% of the adults this year, plus a third of 0.87 JN. Why? First of all, the third is coming from the fact that a third of the juveniles are surviving, but it's a third of the 0.87. Why are they putting the 0.87 in there as well? Good. It's a third of the juveniles that are surviving. It would be ridiculous to say that the juveniles who have died are also going to mature into adults. Okay? So then multiplying a third by 0.87, you get the 0.29 JN. So the first thing that we want to try and do is to try and form the matching equation for the juvenile population in the year n plus 1 under this model, justifying the values. Okay, so we're going to try and work out now what j of n plus 1 is. So what do we think it's going to be for j of n plus 1? How are juveniles, what are the juveniles next year? Where are they coming from?
The birth rate of the adult population.
Good. So some of them, 23% of the adult population from the previous year, they're going to produce juveniles. Okay, so you get 0.23 AN. Plus, what else?
2/3 of the surviving population.
Good. 2/3 of the surviving population of the juveniles. Because 1/3 of those juveniles are going to become adults, 2/3 of them are going to remain juveniles, but 13% of the juveniles are dying, so it's only 2/3 of the 0.87, which is 0.58. So we get 0.23 AN plus 0.58 JN, okay? So then the next part of the question says something a bit more complicated. I'm just going to quickly remind ourselves of what those two formulae are, because I know I'm going to need them on this page. We've got the AN plus 1. What does it say for AN plus 1?
0.97 AS plus 0.29 G.
Okay, and then we said that JN plus 1 was 0.23 AN,
Plus
0.58 JN. I just need that on my page so that I can teach that bit a bit easier. Okay, now they throw in some more information. The total population on the 1st of January 2018 was estimated to two significant figures at 1.5 million zebu, with 1.2 million of these being adults. So if we take the 1st of January 2018 as n is 0, we can then say that the total population we know is 1.2, because the whole thing is in millions. Not 1.2, well, not 1.2, 1.5. And we can also say that the adult population is 1.2, the juvenile population, when 0, would be 0.3. It then says, find the value of P and the matrix M such that the population of zebu can be modelled by this system. This is trying to make things look as confusing as possible. P is just clearly 0.3, because we've said that the adult population, to start with, is 1.2, so the juvenile population is going to be 0.3. So we can state straight away that P is just 0.3. Now this looks unfamiliar, but this isn't unfamiliar. We've got AN plus 1, JN plus 1, where we've got them here and here. And then we've got a matrix being multiplied by AN, JN. So what's the matrix? The matrix is these values that we have here. The matrix is going to be 0.97, 0.29, 0.23, 0.58. Well, I'm going to show you what you've got here. So we've got AN plus 1, JN plus 1. We think it's equal to 0.97, 0.29, 0.23, 0.58, multiplied by AN/JN. Just imagine what happens when you do this matrix multiplication. 0.97 AN plus 0.29 JN, 0.97 AN plus 0.29 JN. You see how it's, just because it hasn't got X and Y, it looks horrible, but it's not. It's just setting up equations again. So now we've got the value of P, and we've got the value of the matrix as well. And you could keep multiplying by this matrix. Every time you multiply by the matrix, you should have the next year. Okay? Can I go on to the next bit? So here is where we're actually going to have to do some maths with this. It says, using the model formed in part B, find to three significant figures the total zebu population that was present on the 1st of January 2017. Then the predicted juvenile population, the juvenile population on the 1st of January 2025. So this one wants us to go backwards a year. I'm just going to write down what we had. We had AN plus 1, JN plus 1 is equal to 0.97, 0.29, 0.23, 0.58. A, N, J, N. Okay, so we want to find out what A minus 1 is. So where is the minus 1 going to be, here or here? So this one, we're trying to find out A minus 1 and J minus 1. Do you get why I want to find minus 1? Because I'm going backwards. It has to be on this side, doesn't it? So if I just erase these little bits that I've got here, here and here, here and here, I'm trying to find out this one. That's the one I want to find out when it's in minus 1, which means that these ones would have to be the ones that are in 0. Yeah, so how do you think I could find, if this is 2018, this would be the year before 2017. What can I do that would find out what this thing is here? Inverse matrix. So I'm going to do 0.97, 0.29, 0.23, 0.58, inverse to A0, J0. What's A0, J0? 1.2, 0.3, and that will give you A minus 1, J minus 1. So A minus 1, J minus 1, if we get our calculators, and we do that, let's do that nice and quick. Matrix 2 by 2, 0.97, 0.58, 0.29, 0.23, 0.58. So we've got 1.22807 and 0.030 blah blah blah. But it wants us to have the total zebu population. So the total in 2017 would be these two things added together. Agreed? So that's 1.228 blah 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 plus 0.030, which is whatever they are. And we add them together. And it wants it to 3 significant figures. So 1.23 million to 3 significant figures. That was for part 1 there. Okay, we're now trying to do for part 2 the predicted juvenile zebu population on the 1st of January 2025. Now, when n was equal to 0, what year were we talking about? 2018, okay? So if we're talking about 2025, we're talking about n is 7, 18, 19, 20, 21, 22, 23, 24, yeah, 25. I always get confused with years and when one of them's 0 and stuff like that when you start with 0. So we want to know what is it going to be when n is equal to 7. So if we're going to try and work out A7, J7, I need to know when it equals 6. But then I need to know when it equals 5. Then I need to know when it equals 4. I need to know when it equals 3, 2, 1. Can you think about what I could do with the matrix? How many times am I going to be applying the matrix? 7 times. So if I'm going to be applying the matrix to the original population 7 times, I could either do it answer, 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 or I could say I'm going to apply this matrix 0.97, 0.29, 0.23, 0.58. I am going to apply it 7 times to 1.2, 0.3. So you can go back to what we've got written on your calculator, and we can apply it 7 times, and we get 2.117 and 0.938. Yeah, it's just you're applying, it's a bit like compound interest, isn't it? So you apply it 1, 2, 3, 4, 5, 6, 7 times. Just the bottom one. So our answer is that juveniles, we predict 0.938. million. Three significant figures. Okay? What does it appear is happening to the juvenile population? Yeah, it appears to be increasing. So the juvenile population appears to be increasing, and the adult population appears to be increasing. You could find out, does the proportion appear to be increasing? Depends, okay? These are all different kinds of things you can investigate. There's going to be an opportunity later in the year to do a research project with UCL for some of you in the class. It's not, we can only do it for 5 of you, so we'll pick them out of a hat. Last year they did population modelling, and they did all of these kind of things as part of the population modelling as well. Okay, so that's part 1 and part 2. We've just got one final part of this. Can I just go on to the next bit? And if you need to, I can always put these bits back at the end. I should know this microphone's going to run out of battery. It then says, as a result of the predictions of this model, the country will export 15,000 juveniles to a neighbouring country at the end of each year. Adapt the model from the 2018 onwards to include this export. So this is kind of hard to spot what you need to do. But at the moment, the current model we've got is that an plus 1 jn plus 1 was equal to our matrix times an jn. What do you need to do to this model? I've used the matrix, I just couldn't be bothered to write it. Yeah, what do I could change the matrix, but actually, look what's happening. Every year, we're just going to add a vector. We're just going to subtract 0. I can't do, for some reason I can't do that kind of stuff in my head. 0.015. Okay, yeah, it is 0.015. Minus 0.015. Now they might ask you to do other things with this. I've seen another question where they ask you to think about, they then talk about, I can't remember the word, older.
Would that be the 2 marks?
That would be 2 marks. 1 for just subtracting and 1 for it being correct subtraction. That's part D of the question. And then part E of the question, state 1 limitation of the model.
I think it will change, like, it won't be consistent. The survival rate won't always be exactly. Everything's rounded.
We would expect survival rates and birth rates to vary year on year. We could say something like, it doesn't take into account, what else might be interesting to take into account? When you think about how a population flourishes, why does a population necessarily do well or not do very well in the wild? Okay, so it doesn't take into account any natural disasters. What else did you say?
Competition.
Competition. Doesn't take into account, maybe there's another cattle there who eats more grass than it does, and maybe their population is going like huge. And if their population is going huge, they're going to run out of grass. What were you going to say, Shaq? Exactly. Competition, so it doesn't take into account how populations of predators or rivals may affect their population. You could also say it doesn't take into account the fact that there may be natural disasters, like Ishraq said as well.
What happens with more than 1 limitation? Would you not get them all?
You should just state 1 limitation, you should just pick your best one, because otherwise it's just like, they just think he's just having a go at all of them and hoping that he'll get one of them right, yeah? So you will come across a weird question like this in a mock exam at some point in your life, and it's a little bit harder than this one, but you just need to stop and think about what is happening, okay? You need to just stop and think, this is just a matrix question. I'm just going to like slow down and just think about the different rates of stuff that's going on, okay? So unfortunately, I don't have any other questions on this to give you because there's only this exam question and then another exam question that I'm saving up, for, which you will get at some point, okay? Are there, I guess I wanted to show you this because it looks like it's really hard. But it's not hard. The thing I think that looks hard about this to begin with is this just looks like, oh my God, I've not seen this before. I don't know what I'm doing. I don't know what n+1 down here means. Just relax, it's fine. You can it just makes sense if you just pause to have a little think about it, okay? So we're gonna finish up there. And what we'll do next is we'll move on to linear transformations.